Good day everyone, and welcome to our fourth webinar in the series on microdrainage. And I'm really pleased to be sat here today with Netsanet, who's been fundamental in driving through the latest release, which is coming out imminently. And I'd like to show you a lot of the extra features coming through with what's new in MicroDrainage 2015. Let's make a start. So the key drivers now behind why we put the extra functionality into the software this time round is coming from the sustainable drainage side of things, with it being microdrainage, and we're trying to better address the balance between the quantity and the quality and the amenity values. So the better balance on the Venn diagram, but even more than that, there's a lot more legislation and standards coming through, which also incorporates the requirement for biodiversity and looking at the environment. So the key driver that's come through for the new module, which is MDSuDS, that I'll share with you shortly, is coming from you. We've been asked to create something that will enable us to look at making space for a variety of structures, maximizing land use, etc. So it'll be a pleasure to show you those functions very shortly, alongside a range of additional functions in the existing microdrainage software. So thanks for all your feedback, and let's move on. So the key three pillars at the end of the day, I'd like to emphasize from previous webinars that we're trying to address the economics along with the social impacts as well as the environmental impacts. And you'll start to hear things like social capital, natural capital. Remember natural capital as I go through, because this is a key driver that's happening across Europe, Middle East, and Africa as we speak. Why are we having to do this? Well, because of the costs. The implications of unsustainable drainage systems are coming home in the developed world, so it's costing us more than we can afford to rectify. So in the new rapidly developing countries, the list of topics on the left-hand side are their key concerns in developing a sustainable economy and really a sustainable country. So those aspects need to be addressed, and we can look at those aspects at a fundamental stage, at the concept of the majority of new developments. Now, I mentioned, remember, natural capital. Natural capital is coming through in a variety of forms, and there is a white paper in England that was debated and discussed at a conference last week, and how we can implement this through the local authorities. There's a massive amount of planning reform going on, and we're all fully aware of the lack of Schedule 4 being signed off in the English arena, but that should be making progress in April through the planning system. So we will be submitting our sustainable drainage systems as a part of our planning applications. I've added in links here, by the way, folks. So when we send out a PDF and we put this up on the website, you'll be able to click on the links and go off to those web links directly. I won't read all of this, but there's a key thing here that's coming through globally, and that is the first sentence here. Government, and in other cases rulers, believe that a healthy, well-functioning natural environment is the foundation of sustained economic growth, prospering communities, and personal well-being. There's a lot of research that's now been taking place, and we know that we have to put the environment at the heart of everything that we do, or we will end up with either economic problems or health issues, etc. And we need to put the community at the heart of everything that we do, particularly with new development. There's a lot of progress that's been made, and there are aims with a range of countries looking ahead to the year 2020, looking ahead to the year 2030, and putting strategies in place on their development. And the same in the UK, and in England, we're looking ahead to the next 50 years. And there are 92 commitments across party. So this is a non-political statement. And there's a lot of progress that's already been made. And you'll see this in the list that I've made out here. It's not just happening in England. There's an Irish forum on implementing natural capital. There's also a Scottish forum on natural capital, and that's going to open up a link to that particular website as well. So I'll try to avoid clicking on those for you. And also in Wales. Now, the Welsh government looked at the draft national SuDS standard that is due to be implemented and found it to be lacking. So I'd like to encourage everyone to contribute to the Welsh Government consultation document that came out in the middle of February. And there's a consultation that will take place throughout March, and the responses should all be in by the end of April. So it's a comprehensive consultation on their interim non-statutory standards for sustainable drainage in Wales. And this is how to design, how to construct, operate, and maintain surface water drainage systems. It's virtually 80 pages long, and I think is an excellent document. And I want everyone to be encouraged to go along and support and point out where we can actually improve this document. It's extremely good, but there are a couple of things that could be improved. But I'll be introducing some of those aspects into the MDSuDS presentation in a short while. Now, we've been tracking with Net sat alongside me here, who's one of the main researchers for MicroDrainage. We've been tracking the current regulation, and this has been going on for forever with the company. But the last 15 years, here's a very brief history, and you can see that the natural environment is the one that's coming through as a strong driver as we speak. And that includes the biodiversity, improved ecosystems. So again, it's all being driven through government and rulers. I was really heartened. So thank you all for filling out the Survey Monkey at the end of the last webinar. And I'd encourage you to do the same after this one. But what I asked last time was, how important are the following aspects in your SuDS schemes on a rating of 1 to 5, 5 being the most important, the maximum. And here's your feedback. Water quantity, no surprise that that's way up there. Water quality was quite high, just under the 4 mark. And then amenity and biodiversity, when I put the question, when I posed the question, I really wondered whether the amenity and the biodiversity would be at a very, very low level. But actually, it's running over 60%. So I was really quite heartened by that. So again, thank you for the feedback, and more, please, we welcome it. So what I'm going to show you now is a systematic design process. We need to take account of natural flows on site, because if we don't, you'll be maybe familiar with this video that I've shown in previous webinars, we're paying the penalty, and that is costing us far more than getting it right first time. If we get this right, we can provide multiple benefits. And what I'm trying to do is encourage people to engage early, maximize the land use to satisfy the developers and the clients, but we have to provide a certain amount of public open space typically. So why don't we use that for a purpose such as conveying surface water? So what we want to do is try to make things more affordable, robust, and maintainable in the long term. Who pays if we get this wrong? We've put in a lot of unsustainable drainage systems globally, and we pay is the answer, because typically this is falling on the lap of the municipalities, on the local authorities across the regions. So we pay for those services, and we're the ones that are going to have to pay for this if we don't get it right in the long term. There are some excellent documents. So there's a lot of work, apart from the Welsh Government consultation and their SuDS interim standards. A lot of the local authorities we've been engaged with have got together, and they're working on a regional scale. So, I mean, credit to so many people here in the southeast, in the west, in the southwest, the northeast, all over the country, in the Midlands. And there are some very comprehensive documents that are coming out with their ideals and objectives, and showing the benefits of what we can possibly do by managing all of these issues on the left-hand side. These are the multiple benefits I'm talking about. Now, if we get this right at concept, if we make the decision early in the concept, we're going to be able to afford to do them. If we do this at the 11th hour, it's going to cost a fortune. So we need to engage early. And what I want to do is show you how to do this to gain a faster approval and have meaningful discussions at an early stage. And I'd like to thank Bronwyn Bunting in Kent County Council and Babesaethan working in Surrey County Council, who have put together an excellent South East 7 master planning document with the aid of AECOM. And here you can see one of the slides that Bronwyn's presented at a conference, showing you that if you make a decision early in the process, this is architectural programming, if you make a decision early in the process, then the opportunity to influence is very great and the cost will diminish. If you make a decision late on in the process, those costs are going to be far higher the later you leave it. So this is all based on good studies, and we can benefit the developers as well as the local authorities, as well as helping the consultants to deliver. The master planning process itself, it is a process within itself, and this goes to show the range of stages that we have to go through, even at the early concept. So we're looking at things like spatial frameworks. We're looking at key connections, the connectivity between what? Between the urban environment and the rural environment. We're looking at connecting green infrastructure. And we need to look at the various functions and the characters of the open space. Now, this is all earthworks and landscaping. So if we can multi-benefit from that work, then we can build in the surface water management, the sustainable drainage approach right at the very beginning. And this is one of the shots of something I'm going to show you very shortly, where we're actually mapping out the amount of space that a structure like a bioretention area or a pond or a swale or permeable paving will take up. So with those multiple benefits, we need to satisfy the needs of multiple disciplines, and we've been engaged very heavily with landscape architects, with an increasing number of sustainability managers and urban planners, and we thank you all for the feedback, and now I hope you'll be pleased with the end result of what we can now show you. So without further ado, I will move over onto the software, and let's take a look and introduce you to our latest in the stable, and welcome to MDSuDS, everybody. This, as you can see, is a blank screen. If you picture this as being just a drawing board, and there are three areas surrounding the drawing board. On the left-hand side, there's a tree view. I'll introduce you to some of these things. And what I intend to do during this webinar is to show you what it can do. And in future webinars, I can show you more how to do it. But at the minute, I just want to give you a bit of an overview on what the capabilities are. So on the left-hand side, there's a tree view with a variety of functions I'll introduce you to very shortly. On the right-hand side, there is a toolbox. You can help build up and model and design various SuDS elements. And along the top, there's a ribbon. So here we have design tools to enable us to do things like calculating greenfield rural runoff calculations. We can look at the first flush. We can look at water quality estimates, and we can look at storage estimates, and we can look at deluging to identify those blue-green corridors right at the beginning. So if we look at the tree view on the left-hand side, and I expand this, if we're looking at a particular project, we need to bring in some information about that project, whether it be a CAD drawing or some ground topography or even an image. So let's start off. If I click on the image at the bottom there, right click, I can load that data in. And by clicking on the little icon there, I've just now loaded in my image. Here's a catchment, and across this whole catchment, I'm planning to focus in on this area here, which is up for development. So we can see there's an existing town area here, and this area is up for development. So I need to bring in initially some topography on the ground to enable us to look at that earthworks landscaping aspect that I was talking about earlier on. And then after I've looked at the topography, we can then bring in the architect's layout. And I'm fully aware that at this moment in time, the way things typically work is you as engineers will receive the layout from the architect, and it's a question of please now make it work. Now define the infrastructure, the roads, the drainage, and make it work. I'm trying to split things around a little bit here to empower you guys to go back to the landscape architects and the architects with some preliminary hydrological information and say, hey, you now make things fit around this, please. Okay, so what I'll do, let me load in the surface. So on the left-hand side, you can see that we've got the image in. If I go to the surface, right-click, and then load in some data, Now, this might be LiDAR data. It could be a grain survey. I'm going to open up a file, and I have a complete phase here. So this is a DTM, which may have come from a land survey, for example. It's now populated the eastings and northings and the grain levels. By the way, we've got a trim option here, so we could trim around to reduce the amount of time it takes to analyze things. If you have a lot of tiles, 7 or 8 LiDAR tiles, so you may have a site in the middle of all of those. I'll maybe show you that at a later stage. And now you'll see that there's a bright green rectangle that's loaded in. So I don't have the topography for the whole catchment. I don't need it. I do have the topography based on where the site's going to be developed. And if I zoom into this area, if I right click, band zoom in, you'll now see a range of triangles, and at the bottom of the screen, you'll see eastings, northings, and ground levels. So when the mouse is off of the ground model, there's 0 depth. If I creep onto the ground model, you'll see that we're something like 561 meters above sea level. I can turn off the image of the surface, and we can see what that land looks like. Now, the triangles don't really help me visualize what the topography looks like. What I can do is right-click on my mouse and go to the display settings and look at the surface. So we have a range of tabs here: layers, surface, deluge. We'll come on to these a little bit later on. And we could visualize the surface by ramping up the colors from green at the lowland areas up to sort of darker brown and light white color at the higher area. So if I say color fill, switch that on basically. I'm just switching the light bulb on to show you the color in the background. I'll just move this to one side. So now you've got a little bit of a feel of what that topography looks like. This is the higher land here, the lighter white area. Then the darker brown is sort of sloping down to the lighter brown. And then the lower land is over to the western side of the site. A little bit of a gully in there. What we can do is we can adjust these colors, and if we adjust the colors, we can save that file out. So you can open up files based on a contour display that you might like, or surface display that you might like. If I say open to one that I've done earlier, Blue Peter style, you can see that I've got a minimum and a maximum, and I've just put in some distances that have got sort of rounded figures: 570 above sea level and 565 above sea level, etc. So you can adjust these to suit yourselves and then save out if you've got a particular view that appeals to you. And we have a legend on the left-hand side here as well. If I just open up the surface data, you can see here that we can switch on and switch off a legend to orientate ourselves. That's fine. I'm going to live with this right now, and what I'll do is load in a CAD drawing on what the architect's created, and then after we've loaded in the CAD drawing for the development layout, I'll deluge to see where the water's going to try to run. So this will then be information that you can pass on and share with the landscape architects and the architects to try to then create these blue-green corridors and provide the connectivity that we're all looking for. Where do I do that? Well, there's a deluge on the tree view, so I could right-click and hit go, and I'll get a little dialog box pop up, so I can deluge from there. I'll close that. I don't want to save that. If I go up to the top here and show you the design tools again, these are the preliminary tools that we typically use at the start of a project. So deluging, looking at the rural runoff characteristics, maybe doing a quick storage estimate to look at those volumes we're going to need under the ground. But let me click on the deluge here, and then the same pop-up box will appear. The program's going to split the model into 4 meter by 4 meter grid squares. I could go 1 meter by 1 meter, but this is fine enough for my purposes. The starting depth of water across the surface could be anything that we want. I'll leave it at 50 millimeters and see where that flows over a 60-minute period. But say OK, This is the program now splitting that grey model into grid squares and then identifying where that overland flood routing is going. And we can see that we've got water everywhere. If I right click on the screen and pick up those display settings again, now we can look at the key for the deluging. And this is telling me that we have a range from sort of 0 up to 670 mil. You can see the coloration here as I run the mouse up as to what that looks like. Again, I could load in one that I've done earlier, and I've got a deluge that's opaque. So we'll just say OK to that, close that down, and I'll click off the arrows. These are the direction arrows of the flow across each of those 4x4 meter grid squares. So that's kind of helpful when we're looking at identifying sub-catchment runoff areas that I'll get into in a little bit. But let me switch off the arrows right now. And what I've done, I've set up this file to concentrate on the deeper water, to concentrate on those blue-green corridors. And you can now see, I hope this is going to be visible, it's maybe blending in with the background a little bit, but on my screen, I can see there's a blue corridor running down here. The green is deeper. At the bottom of the screen, again, you'll see extra figures. So you'll see the depth of water sitting in the green areas. So the water is going to flow from the east down towards the west and then pond in these locations here. There's a pond here and in the northeast corner. And the water is going to flow down this way as well. So already we can get a flavor and a feel as to how nature is going to try to run its course. Can we live with this or not? Well, let's load in the CAD drawing and see what the architects produce for us. So if I right click on the CAD data and bring in my CAD drawing, I'll explain what this is about with apartments in the northeast corner. We've got more development happening here and on the western side with some properties with a little bit more land towards the southern area. This is essentially grassland right now with a few properties at the bottom. So there are really sort of 5 sub-catchments that we're kind of looking at, and I'll illustrate that again in a second. But already I can see where the water wants to basically pond right outside the apartments. So would that be an idea to put something in place like a bioretention area? If there's already some depressions there, we can do a little bit of earthwork landscaping and then maybe benefit from putting something meaningful in there right at source. So we're trying to really slow down the flows. We're trying to provide things right at source across the site and maybe some regional control as well. Let me switch off the deluge. This is just the visuals of the deluge. And we're now focusing on the development itself. And what I can do is show you those 5 sub-catchments. And if I click on the left-hand side, you'll see there are a range of things saying connections, drainage systems, inflows, inlets, and outlets. I'd like to explain the process that we've run through on designing the SuDS system for this development. We start off with looking at inflows. Now, the screen's gone a little bit green over the development area. And if I click on the top right-hand side, you'll see that there's a polygon that's now shown grey. And that's a polygon of a sub-catchment. So there is runoff being generated from that sub-catchment, and there's some kind of a flow coming from it. Going to where is the structure that we need to design, and how it's getting into the structure is through an inlet. And will it then flow out of the structure, infiltrating into the ground, or will there be some kind of a positive discharge? Will be the outlet. So I'm going to go through a little bit of a process. And I'll just band zoom into the northeast side. So we can see that we've labeled this Lakeview Apartments. And within the development, we now have runoff of this subcatchment. If I double click on the icon, this is the extent of that grade polygon behind, 0.632 of a hectare. Now, how does the runoff run off and get into the structure? You'll be pleased to know there are 7 different ways that you can generate runoff, all the UK methodologies, plus Lawrenson for Australia, plus SCS, happening across the States and a lot of the time in the Middle East. And even with the time of concentration, one of the questions that's constantly asked of me is, how long does it take for the sheet flow to run off and enter into my structure? Well, if I click on the little calculator button here, I'm really delighted to be able to share with you 9 different ways of calculating sheet runoff based on the time of concentration methodology. Again, everything from the UK methods across to the US and everywhere in between. So this is something I've been asked for many years. So there you go, folks. I hope you appreciate that. So we now have this area running off, not just the runoff. Don't forget, we're trying to provide multiple benefits. So we also have to look at the concentrations of pollutants. So we can put in background concentration of pollutants. And in this model, we've just got about a half a dozen of them. You can have more. We can set that up. I'll show you that in another webinar. But we're looking at quantity of the water as well as the quality of the water. So that's the runoff being generated. Where's it going to? Well, I can now switch on the drainage system or the drainage systems. And this is showing you the extent, literally the footprint of a bioretention area. Now it's flooding just a little bit down here. So my rationale is if we just massage the landscaping around and then create the pit here with infiltration layers, with filtration layers underneath and landscape it, we could fit that in here right at source and take account of that runoff with maybe some positive discharge flowing down to the next system as well. Let's see what this comprises of. So I'll double click on the lake view bioretention area, and you'll see that here are the dimensions of the ponding area itself. We could have filter under drains or not, as the case may be. We have filtration layers, so we can set up the layers of that. If I just click on an image, basically this is what it's going to look like. So we can build up filtration layers under the ground, from gravels to sands, to filter and take out pollution. We can put in the depth of those layers. We can put in the porosity of them. We can put in the filtration rate through them. So, hey, what we can now do, we can actually now analyze the flow through every single structure in a development. With regard to the advanced, we could look at infiltrating into the ground, or maybe just using this as attenuation. In this case, we're ignoring the infiltration for the ponding area above the surface, but below the surface, we're looking at infiltrating into the soil at a rate of 0.1 meters per hour. If we look at the pollution aspects as well of the bioretention area, we could add in that detailed methodology of analyzing how we can remove pollution. And as I say, we're limiting ourselves to 6 of the core ones here, but you could add in more if you want. We could put in background concentrations here, and then we can analyze either the percentage being removed based on this particular structure, or we can even analyze the first order of decay. So in other words, we can look at the loadings and the concentrations, the buildup, and take an analysis to the next level. This was what I was desperately hoping to go into the national SuDS standard. It's something that's been known for so long now. We're doing it in other parts of the world. Why we're dragging our feet here, I really don't understand. And I'm aware that the SuDS manual is being rewritten, and there are some loadings and some water quality aspects being enhanced in the new SuDS manual that will replace C697 by June, July of this year. So we'll keep you posted with that, and just be reassured that basically whatever goes in there, I'm pretty sure we've got it covered already. If not, we'll endeavour to do our best to make sure that we can make sure that you can comply in short order. Looking at the filter pollution, so that's the ponding pollution, essentially above the soil level, where the basin is ponding, but then below the soil level through those filtration layers, we've added in those percentage removal characteristics. But as I say, you could have put in first order of decay as well. So now we have runoff. We have runoff coming from that subcatchment, getting into this structure. And what we need to do is understand how that's getting in. So if I click on inlets, there's point inflow. So the runoff from this subcatchment is getting into the bioretention area as point inflow. If I double click on the icon here, this is telling you that we have 100% of the runoff entering into the structure. So there's nothing of that runoff bypassing. And maybe the best way to describe that to you would be, imagine in the highway to the right-hand side here, maybe we have a structure that happens to be a gully or a pit, and we have flow coming down the channel of the road, and it gets to the gully or the pit as point inflow. Maybe because of the longitudinal slope of the highway, you're going to get some of the flow entering into the gully, but then there's maybe 80% of it, 20% of it, 10% of it bypassing and going down to the next gully. So we can model those kind of aspects as well. So we have the runoff entering into the structure as point inflow. I switch the inlets off. And then how about the outlet from the structure? So I'm just switching on the outlets, and I'll switch back on the bioretention area. So from the bioretention area, we have some infiltration going through the filter media, as I showed you just now, at a rate of 0.1 meters per hour. And you have now an orifice control, which is essentially providing you a positive discharge and outflow control that's at a 100 millimeter opening size. So that is now passing to where is the final link in the chain, connecting through a connection. So I've just switched on the connections. And you can see that the orifice is now connecting with no delay into this structure to the left-hand side. And that structure to the left-hand side is porous or permeable paving, pervious paving. If I double click on the connection, how do we set this up? We could have no delay whatsoever. It's saying no delay in the label, but actually we set it up as lagged flow. And what do I mean by lagged flow? I can change the name here and say lagged, and then put in bracket number 2. It's kind of link number 2. So we're saying that the velocity through whatever this is, and this can be a pipe, it could be a channel, is flowing at 2 meters per second. We could put 1 meter per second, whatever that particular characteristic of that connection is. And it will there tell us the time of travel from the orifice down through the connection and entering into the next downstream structure. In this structure, same thing applies as the bioretention area. We have all the information that we need. So we're now really accurately modeling the flows all the way through. The other options that we could have chosen here would be attenuated flow. So it could be no delay, an instantaneous transfer of the flow through the 100 mil orifice. Could be lagged based on that time, or it could be attenuated as well. So we're building into that connection, into that pipe, an attenuation. We're surcharging it and holding back the flow, slowing it down a little bit. And as I say, we could put in pipes, rectangular channels, trapezoidal channels, etc., etc. And I don't want to make any changes to that. So if I switch everything on and then zoom back out, I'll go back to, I could bookmark this, by the way, and say Lake View Apartments in terms of the view is what I'm thinking. I could add that as a view that I could go back to. And then if I click on here and then pan out a little bit, I could now bookmark this view and say site overview, and then add that. So in other words, if I wanted to zoom back into the lake apartments, I could say, right, go to the lake apartments, and if I want to go back to the site overview, I can go back to the site overview. Okay, I find that really, really useful, particularly when we're doing this kind of work, and particularly where we're looking at things really holistically right now, based on deluging the site, seeing where the depression areas are, and then see if we can massage the landscaping to suit. We're obviously not going to put a pond or bioretention area in amongst these houses and properties here. I'm not suggesting for 1 minute that you do. But where we can, maybe we could introduce things like swales, which is what we've done here down alongside the highway. And then we have got a pond where there is open space to the west of the site. Remember where we had the deluge earlier on? If I put the deluge back on and turn the arrows back off, that's a little bit busy. Okay. You can now see that we're kind of matching up the structures to fit where the ponding is taking place, on account that I'm thinking there's less excavation, so there's lesser works, less cost, maximizing the land use, trying to satisfy the developer's need, along with the approving authorities in short order. So let me turn the deluge off. It looks a little bit busy. And there's our completed model. So we've connected the bioretention area into a porous car park. This now is connected through to another bioretention area that connects into a pond. And we have another system coming from this little grassland area, runoff from the highway here, from the street, coming down through into the pond. And then we have the properties here discharging into a swale. And the flow into the swale doesn't need to be point flow. We could also have sheet flow coming in, lateral flows coming into the swale as well. So at the minute, we've got essentially 3 different systems, all traveling from east across to the west, feeding into the pond. And we can see that we have flow paths. So there's an access road going across to the outfall. So this access road is coming across to the outfall. We can look at some profiles of this. I need to adjust some levels and look at I've got another file that I've done an adjustment on the levels with this. We can show the profiles for the grassland. Same thing, we've got a low level down here, I know, within the model, so it looks like it's diving underground. But we have profile views for all of the aspects, and from the apartments, from the Lakeview apartments down, we can see the profiles. Fine for the holistic and the concept, because we're just taking flows from one area to the other and master planning and scoping these things out. What we can do is we can analyze how this is working right now. So we haven't put in all the pipes and manholes. This we can do in really, really short order, but we haven't designed the whole network yet. We're just still at concept stage and providing some sort of meaningful options. And with the phasing and the phases, we could make another copy of this and provide 2, 3, 4 different scenarios, discuss around the table with all the stakeholders, narrow down the solution to one preferred choice, and then away you go into full microdrainage and carry out the detailed design. But what we can do for this, we can analyze. So if I just look at the analysis criteria, I'm just coming here to make sure that I got some rainfall selected. Say okay to that. I can validate, because it's a bit of a holistic model. So I click on validate and see if there's anything that needs adjusting. So that level, there's a level that's one of those crazy levels I was talking about that needs to be sorted out. Let me have a look at what we've got there. Okay. And if I went straight to analyze and then hit go, it would come up with the same prompt. So I need to make an adjustment to that level that I mentioned was a little bit crazy earlier on. So if I go to open up the one in Blue Peter fashion that I've done earlier, If I go File and open up, I'm not going to save what I've done here now, but I'll come down to this one here. I'll show you the flow paths from the apartments to the outfall, and this is where that level at the downstream end has been adjusted. I just wanted to show you that you've got a kind of an auditing validation tool, even though we're in design mode. So it'll flag up anything that's a little bit erroneous to help you to get a reasonable result right at the get-go. So this is obviously flowing from sort of left to right, although it's like east to west. So you have all the information here of the bioretention area. We've got the paving, the inlets, the outlets, etc., down to the pond. So now if I go to the analysis and click on the go, here it's saying, I don't have any rainfall. So what I'll do is I'll go to my analysis criteria. As I mentioned before, I wanted to make sure that I had rainfall selected, which it was, but I had the error in the model invert levels. I say apply that rainfall to the model. Now I hit green for go, and we run the analysis. Looking at the time, and I should see moving on. So I'll look at the results. I just really want to show you the results because we've got some very comprehensive outputs that I want to share with you. Based on each of those different structures, we can see on a storm duration by storm duration, I happen to have run the 30-year return period, 15-minute to 1-day winter profile storms. And we'll get into more detail on that in future webinars. But for each of those structures, you can see on a storm by storm basis how they are performing. So the status of the structure, whether they're okay or surcharging, flood risk or flooding. In terms of the results, we've got all the drainage systems, which is what I've just shown you. You have all the storms. So for each of the structures, you could look at each structure independently, looking at all the storms. And you have phase management. We only have the one phase, but what we could do is we could compare the pre and the post development. And we could do that in terms of the hydraulics. So here's your volume going in, the volume going out. So we've got some infiltration, etc. There's the inflow, there's the outflow, and we could also look at the pollution. So we've got the pollution in terms of loadings, the total event load, and also the concentrations, and how those concentrations have been affected. So as you can see, there's a massive amount of information that you can extract. We can also run phase reports. I'll hit the update preview on here, and this is generating, I expanded all of these trees, graphs, pollution results, hydraulic results for everything across the whole site. It takes a minute or so to run because there's so much information in there. And you can now scroll down through and see what's occurring for each event. Of course, all of this we can save out and we can print. Just to show you that it's not just about getting the information, it's all about extracting it and having this graphically produced so that you can have meaningful discussions right at the get-go. On the right-hand side, just to share with you all of this information, how we built things up, like the bioretention areas, left-click, drag, drop it onto here. How you set the inflows up, left-click the area, drag it, drop it onto here, create the subcatchment inflow into the structure. So more of this on future webinars. But I'd like to move on because I'm desperate to show you the extra functions that we've added in that you've requested into MicroDrainage as is. So within System 1 and within the DrawNet CAD modules, something that I'm asked for all the time when I go to the Middle East, where the land is relatively flat, is please can we set up for a particular slope or gradient on a particular diameter of pipe. This is the way that a lot of the projects are run, where the authorities are quite happy understanding what the gradients are to achieve self-cleansing velocities of either 0.6 or 0.75 meters per second. So we've added this into the program for you folks. If I go to the network information on this job and look at the design criteria, on the left-hand side you can see the storm network details, and you have a range of slopes based on various diameters of pipe, and you can see the long section on the right-hand side, which is complying with our 1.2 meter below ground level optimum depth. If I go to the design criteria now and click on the pipes, the little pipe size editor on the right-hand side, what we can do is we can change that standard pipe size to one with fixed pipes. So if I go to my desktop, and here I've got a fixed slope pipe size file, and if I open that, here are some typical examples of what we're asked to do based on those diameter of pipe. So if it's a 100 mil pipe, lay it at 1 in 150. If it's a 150, lay it at 1 in 175, etc., etc. If I say OK to that, now what's going to happen? The program is going to come back and look at the design criteria, and it will try to lay things to make sure that there's a 1 meter per second self-cleansing velocity. But I've already said I know that those slopes are going to provide less than 1 meter self-cleansing velocity. So I'm just going to adjust that to make sure that there's no override. And I'll put the minimum velocity for auto design down at, say, 0.1. OK to that. If I now go to the storm network details, notice the little icons on the top here. We've got a set auto design to allow for all pipes. We've got a set auto design to not allowed for all pipes, which is basically locking everything down. And then set auto design to fixed slope for all pipes. So if I click on that, it's coming up with a note. Am I sure that I want to set up the auto design to fix the slopes for all the pipes? And I'm going to say yes to that. And you can see that on the left-hand side now, all of those pipes have now got the slopes that have been specified in that pipe size file. And it's also showing you the consequences. We've got a little branch line here that's going off under the topography there that's dragging everything down. But we have pipes coming out of the ground. Now, this doesn't surprise me because this is a relatively hilly site. And as I said, this is where it's prime for a flat site, where you've got a flat site and you're trying to minimize the depth. So if that topography was flat everywhere, then we'd end up with those gradients running all the way through at a shallower form. It will end up more working out more cost effective. So let me just shut that down and shut the long section down. And we go back to the plan view. Another really strong request that came in was to look at things like deep bore soakaways. So what we can do now is we can add in deep bore soakaways into our models. So when you're looking at simulation and source control, on the plan view, I could pull up a toolbox, and let me just zoom in to any of the manholes here and look at the structures, looking at all the variety of structures. These are all the ones that you'll be familiar with, I'm sure. And then we have deep bore soakaway. So if I left click and then drag and then drop onto any of the nodes, we now have a little window that's set up to enable us to specify a chamber at the head of the borehole. So what it's doing is looking at the cover level, and we can now put in the invert level below. So let's say the chamber is going to be like a couple of meters deep. So 151.695 would make it 2 meters deep, 695. What's the diameter of the chamber? Well, maybe it's, we're in meters, so 1.5 meter diameter, whatever you want to put in there. If it was a rectangular chamber, you put in a width and then the length. So I'll ignore the length. What's the diameter of the borehole? Well, normally they're 150, aren't they? So we'll put in a 150, 0.15 meter borehole that's maybe 25 meters deep. And What about, so now you have a little sketch showing there's the chamber, there's the borehole. What's the infiltration through the very base, through the bottom of the borehole? This one's for you, Paul, 0.2 meters per hour. And now what we can do is we can set over on the right-hand side incremental depths. Then we go every sort of couple of hundred, and then insert. So imagine if we have this borehole going down through, but punching through layers of clay. So there'll be certain areas where you're going to have zero infiltration as you're punching through the clay layers, but you may have a nice free draining alluvial deposit at the bottom. So what we could do is we can change the infiltration coefficient. 0 is at the bottom, and then 25 meters is at the top. So what I could say, let me put in a figure of 0.2 again, and then repeat that. So we're infiltrating now out through the sides at a rate of 0.2 meters per hour, up to say 20 meters, so 5 meters below the surface. And then I'm going to say there's 0 because we've got a clay layer at the top 5 meters. Okay, so this is just showing you where I'm at in the depth gauge there. I'm going to cancel that because that's how I set up one earlier. And what I'll do now is just show you, if I go to my window, I've got a stormwater SuDS scheme that includes a deep bore soak away. And if I have a look at the network and the structure, there it is, right at the head of the system on manhole number 1. So this is how I set the thing up earlier. And then I have one without excluding a deep bore soak away. So if I go to the network and if I go to the structures, there's nothing up at manhole number 1. Now, when I hit green for go, I'll just say OK to that. And save out the results. We can see that when we don't have a deep bore soak away on manhole number 1, we've got a little bit of flooding. There's only 5-6 cubic meters of it. But if I switch that across to the deep bore soak away model, we've taken the flooding away, basically. So it's doing its job, in other words. If I have a look at the long section and then scroll over to the left-hand side, you can see it's shown visually as a sort of orange line here with a very, very low invert level on the left-hand side. This also now brings me on to showing you things like results. We've got some really good additional help on extracting the results. So if I click on the results drop down and the volume summary, I'll close some of these windows behind, it's getting a little bit busy. What we can do now is looking at all of this particular network. Let's see what the static volume, what's the volume available within the pipes. So if I click on the left-hand side here, you can see show the static volume that's available within each of those pipes within the network. So I've added on another column, so you can now see the volume within the pipes. And it's now accumulating the total volume that we have under the ground in effect. How about the volume associated with the manholes? So if I switch that on as well, you've got the volume and it's all being summated at the bottom of the screen as well. And what about those structures? So we add in the structures and now we can see on a job by job basis, okay, scenario by scenario basis, you can see whether you have got the appropriate volume under the ground to meet your quick storage estimate at a glance, even without analyzing the hydraulic nature of that performance of the site. And any of these you can switch the others on and off, etc. It'll help. In this case, you've just got the one structure right at the bottom there, as well as our deep bore. So it's essentially telling me at manhole number 1, we're gaining 14.577 cubic meters of volume in that 25 meter deep borehole. Okay. The other thing that's incredibly helpful and productive for you is looking at extracting this information, the results basically, from the print option. So we can do this kind of live. And if I expand the print view, looking at the results, we can now click on the summary of results. And on the left-hand side here, notice that we've got a default setting. So that's what we would normally extract. But also, what about following the summary that I've just shown you? So I could click on summary, update the preview. You can see the information. So this is an extract of that summary. If I just zoom in a little bit, because I know that's very small print. Now, the date and time is taking up a lot of space here. I'm not particularly worried about the date and time myself. So the other option here would be to set my own preferences. So I don't have to go all the way back to that screen within the summary to set up the preferences. We've put the summary of preferences option right alongside the print style. So what I can do now is just switch off what I don't really need. So date, time, I'm interested in the cover level, the water level, surcharge, depth, flooded volume, take out the flow capacity, and the overflow I'll leave in, and the pipe flow. So okay to that, and then update the preview. And there you go. It's instantaneously reflected that and set it up, so I can now go away and literally save that, print it, away we go. I'm getting looked at here, folks, so I'm going to have to go back to the presentation very briefly because I'm rapidly running out of time. So apologies for overrunning there, but hopefully you can sort of start to get a feel the richness of the functionality that we've added in, particularly in MDSuDS, which is going to help you right at the get-go to prepare for those local sustainable drainage system standards that should be coming out in April. Let's see. If they do, you're covered. Don't worry about it. If not, we've got to go this way anyway. We cannot carry on with traditional drainage systems because they have limited capacity and they continue to fail. So there are other parts coming through the planning system on environmental capital, natural capital, that are going to swing things around this way as well. So I hope you've enjoyed the additional functions that we're bringing you. We'll send out a Survey Monkey and would welcome any feedback that you have and anything that you would like to see in future versions. We're already started on version 2016, and 2015, as I say, is coming out imminently. If I tell you a date, I will be hung, drawn and quartered, but it's complete and it will be rolled out and it will be happening over the next few weeks. And otherwise I'm going to get strong. The MD says we're satisfying those three pillars. We're looking at the economics at the get-go. We're looking at the social impacts and the environmental impacts. And I really see a major drive coming through from the local authorities to satisfy all those needs, particularly through the planning system. And if we can help you to do things quicker, easier, and gain faster approvals, that's going to be all to the good for your clients and developers. Look forward to receiving your Survey Monkey feedback, and I wish you all a really good month. The next webinar that we're planning to hold is on the 8th of April. I look forward to engaging with you then. I'll maybe put in a question on the Survey Monkey to see what you'd like covering in more depth. I have ideas, but I'd love to just satisfy your inquisitive minds. Thank you for all the questions, which I'm going to have to pull together and satisfy under a separate FAQ. Meanwhile, have a great month and take care, everybody.